the ratio of change in dimension to the original dimension of a body, that is nothing but strain. The maximum point up to which the body can regain its original size or shape is called as elastic limit. So if the point D and E are close to each other, then the material are said to be brittle. If they are far from each other, then the materials are said to be ductile materials. Hello everyone. Welcome to session 2 of chapter 9, Mechanical Properties of Solids. This is Swati, Faculty of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. In our previous session, we have studied about what is a rigid body, what is deforming force, what is the meaning of restoring force, and the elastic behavior of solids, and also the concept called stress and types of stress. So in today's session, we are going to discuss about one more interesting and the important concept, that is strain. So the term strain, how it is defined as? So strain is defined as the ratio of change in dimension to the original dimension of a body, that is nothing but strain. It is defined as the ratio of change in dimension to original dimension of a body. Since strain is the ratio of same physical quantities, it has no units. Let us understand this with the help of example. Here I have taken a spring which is attached to a rigid surface which is having a hook. The length of the string initially is L. The original length of the string initially is L. When it is attached with some load of weight mg, we can observe the stretch in the string, which means that causes a elongation. The length will change. So the change in length is this much and it is denoted by delta L. So delta L is nothing but the change in length, which means here the strain can be defined as change in dimension. The dimension in this example which is undergoing change is length. So change in length is given by delta L divided by original dimension is the original length of the string, that is L. So with this example, what we can understand, the strain is defining, it is dealing with same physical quantities. In numerator also we have length, in denominator also we have length. But in numerator we have change in length, it is again a length. Since they are same physical quantities, strain has no unit. If you write the unit for this, it will be meter because that is length again, and this is also meter, they will cancel out and hence strain has no unit. There are three types of strains. As we discussed the types of stress, we had three types, that is longitudinal stress, tangential or shear stress, volume or bulk stress. Here in case of strain also we have three types. One is longitudinal strain, the other one is tangential or shear strain, volume strain or bulk strain. Let us now study about all these types in detail. So the first one is longitudinal strain. I have explained about this, the term longitudinal, in the discussion of stress also. So longitudinal is a term which says about the dimension, that is length. So we know what is strain. Strain is nothing but change in dimension to original dimension, and longitudinal strain is nothing but the ratio of change in length to the original length due to the longitudinal stress is called as longitudinal strain. It is given by delta L by L, where delta is nothing but the change in length and L is nothing but the original length. So the final length, look at this example, we have a cylinder whose original length is L. When the stress is applied, longitudinal stress is applied, we can observe a change in length. Correct? Here the strain is defined as change in length, that is delta L divided by L. So after the stress is applied, the length changes and the final length becomes L plus delta L. So the next one is shear strain. So what is the meaning of shear strain? How it is defined? It is defined as the ratio of relative displacement of faces delta x in this example to the perpendicular distance between the faces, that is L in the example, when the tangential force is applied. You can observe this example here. This is the tangential force what we are applying on this object or on this body. When the tangential force is applied, we can observe the relative displacement of the faces. For example, if you hold a book and try to push the upper surface of the book, you can observe the lower surface also moving in the opposite direction. That is the relative displacement. So when the tangential force is applied, there is a relative displacement of faces. So here in this example, L is the perpendicular distance between the two faces. You can observe this is phase 1 and phase 2. The perpendicular distance between the two faces is given by L. So shear strain is the ratio of relative displacement. Relative displacement is given by delta x to the perpendicular distance between the faces, and that is given by capital L when the tangential force is applied is called as shear strain, or it can also be defined as the angle through which, you can observe this is the angle through which the vertical face of a body is displaced when tangential deforming force is applied. When the force is applied, you can observe this face will move, it will displace, the vertical face will displace, and you can observe the structure like this. So this is nothing but the angle of displacement. So shear strain is also defined as the angle through which a vertical face of a body is displaced when a tangential deforming force is applied. So it is defined as shear strain is equal to ratio of relative displacement, that is delta x, to the perpendicular length between two faces, that is delta x by L, which is generally given by tan theta. Here theta is nothing but the angular displacement of vertical face. Generally the angle of displacement will be very small. Since the value of theta is very small, this can be, tan theta can be written as just theta, and hence the expression for shear strain is given by theta is equal to delta x divided by L. So the next type of strain is bulk strain. It is nothing but the ratio of change in volume to the original volume. Here which dimension I am talking about? The volume. We know what is strain. It is change in dimension to original dimension, and in bulk strain the dimension we are talking about is volume. So the definition for bulk strain is the ratio of change in volume to original volume of an object when it is experiencing a hydraulic stress. So it is given by delta V by V, where delta V is the change in volume and V is the original volume. You can observe this example. Here this is the original volume of a body when it is undergoing a hydraulic stress, or when the pressure is applied in all the direction, the volume gets decreased. So the volume will change, and hence the volume strain is given by change in volume by original volume. So next important topic is Hooke's law. Hooke's law is very important concept, examination point of view. So let us now study the statement of Hooke's law. It states that within the elastic limit, stress is directly proportional to strain. We know what is the meaning of stress. We know what is the meaning of strain. It is saying that within the elastic limit, the stress and strain are directly proportional to each other. What is the meaning of elastic limit? Elastic limit, the name itself says the maximum point up to which the body can behave as an elastic material, or the maximum point up to which the body can regain its original size or shape is called as elastic limit. So within that elastic limit, the stress and strain are directly proportional to each other. We can analyze with the help of graphical representation. Here I am varying strain along x-axis and stress along y-axis. You can observe as the stress increases, strain is also getting increased, and hence we get a straight line. This straight line represents that these two quantities, that is stress and strain, are directly proportional to each other. It is represented as stress is proportional to strain. To replace this proportionality symbol with the negative sign, we need to introduce a constant, and hence we can write this expression as stress is equal to K into strain. What is K here? K is nothing but the proportionality constant, or it is also called as the modulus of elasticity. We can also define the modulus of elasticity with the help of this expression, that is K is equal to stress divided by strain. And the next interesting and important concept is stress-strain curve. There is a greater significance of this stress-strain curve, which means we can study the behavior of the metallic wire or a substance by plotting a graph between stress and strain. So this is a very frequently asked question, and it is very important examination point of view. The question will be like this: what is stress-strain curve, and explain its properties. We must know what stress-strain curve is. It is nothing but the plot of variation between stress and strain for a given material is called as stress-strain curve. We can analyze the property of a metallic wire with the help of stress-strain curve. You can observe this diagram carefully. Here, along x-axis, I am varying strain. Along y-axis, varying stress. These two are very important. Representing stress along y-axis and strain along x-axis is very important thing we have to keep in mind. And you can observe here we have different points called A, B, C, D and E. And we have different names for these points. We need to know about the meaning of these points and we have to explain each and every single point. So let us study about this one by one. When a metal wire is stretched for small value of load, the elongation produced is proportional to the load. You can say that it is nothing but for small application of load, the elongation or the strain produced is proportional. So stress is directly proportional to strain up to point A. You can observe this graph. Up to point A, we have a straight line. I told you in the explanation of Hooke's law, if the straight line represents the stress and strain are directly proportional to each other. So in this graph, up to A, the stress and strain are directly proportional, which means for small load, the elongation produced is also small. As the stress increases, strain also increases, or stress and strain are directly proportional up to point A, and hence the point A is called as proportional limit. We must know about the meaning of each and every point. As I told before, A is called as proportional limit because up to this point the Hooke's law is valid, which means the stress and strain are directly proportional to each other. Stress corresponding to point A is called as proportional limit. So the next point, when stress is increased beyond A, you can observe here, if the stress is increased beyond A, we can observe a small curve. The line is not straight, which means for small amount of stress, the strain caused is more. Here, the point B is called as yield point. I'll tell you the significance of this point. Up to point B, the material can regain its original size and shape. Here, after A, here, beyond A, if the stress is applied, the strain caused is more. There is a large strain up to point B, so that the stress is not directly proportional to each other. Even though the stress and strain are not directly proportional to each other, the body can regain its original size and shape when the applied load is less than certain limit. And this limit is called as elastic limit or the yield point B. Metal shows elasticity behavior in this region. Now, how to define elastic limit? It is nothing but the maximum stress up to which the body can regain its original size and shape is called as elastic limit or yield point. You can observe here the stress which is corresponding to the yield point is called as yield strength and it is denoted by sigma y. So next, if the stress is increased beyond B, you can observe here, what if the stress is increased beyond B? Say for example, at point C, the material will not regain its original size and shape. If the stress is increased beyond B, strain increases further rapidly. Now if the load is removed at point C, the material will not regain its original size or shape and hence the strain produced in the material is permanent and it is said to have a permanent set. Such a strain deformation is called as plastic deformation. At point C, the material will not regain its original size or shape after the removal of load, which means it is said to have a permanent set and hence the name permanent set at point C. Now point D on the graph is called as ultimate tensile strength. What is the meaning of ultimate tensile strength? You can observe if the stress is applied beyond C up to D, D is called as tensile strength. So the meaning of tensile strength is nothing but the minimum stress needed to cause the fracture of a material. That is the minimum stress that is needed to cause the fracture of a material is known as ultimate tensile strength. As the stress increased further beyond D, if the stress increases further beyond D, at point E, we can observe the fracture of the material. The material will get break. Up to point E, it can be stretched, but at point E, it will lose its elasticity property and the material can get break. And hence, point E is called as fracture point, where the fracture occurs. This is the significance of stress-strain curve, where we can understand the behavior of materials. So the next important topic is elastomers. What are elastomers? How to understand elastomers? What is the best example to understand elastomers? Elastomers are nothing but materials which can be stretched to a large value of strain without breaking is called as elastomers. For example, rubber. You can observe the change in length of the rubber. You can observe the change in dimension of the rubber as you stretch it, which means there is a cause of strain. So, the material which can be stretched to a large value of strain without breaking, they are called as elastomers. Rubber is one of the best examples. So, what is the meaning of ductile material? What are brittle materials? A ductile material is nothing but the material showing large amount of plastic deformation between the elastic limit and the fracture point are called as ductile materials. Ductile materials can be drawn into a thin wires. For example, steel, which means it can be understood with the help of stress-strain curve, that is the material showing large amount of plastic deformation between elastic limit and the fracture point. They are called as ductile material. The material showing small amount of plastic deformation between the elastic limit and the fracture point, they are called as brittle materials. Example for brittle material is glass. Now, how to analyze this brittle material and ductile material with the help of stress-strain curve? If the points D and E, they are close to each other, if the point D and E are close to each other, the fracture occurs soon, and the materials which undergoes fracture soon, they are called as brittle materials. Example, glass. Similarly, if the points D and E are far apart, then the material is said to be ductile because we cannot observe the fracture soon that happens in a ductile material. So, if the point D and E are close to each other, then the material are said to be brittle. If they are far from each other, then the materials are said to be ductile materials. So, in today's session, we have discussed about few interesting concepts of mechanical properties of solids. In our upcoming sessions, we are going to discuss about few more interesting concepts. Until then, take care all of you. Thank you.